To support conservation, uh, so some of the uses of this bioacoustic monitoring is to detect and prevent illegal logging, poaching, and also enable biodiversity measurement and monitoring. Listen on to learn about how artificial intelligence and passive monitoring and sensing has become very critical for conservation across the world. Welcome, Boran. It's a pleasure to have you on this podcast to talk about Rainforest Connection.
Sure.
Why are bioacoustics being increasingly used in conservation?
Yeah, well, bioacoustics is certainly not a new field of study. It's been around for years and years and years. But in the last few years, it has advanced with the use of AI, with the use of passive acoustic monitoring, where it really became one of those ways to understand what biodiversity looks like in an ecosystem. The beauty of bioacoustics is that with sound, you can listen all around you, 360 degrees. It's very passive, where you can install a small offline device, record the entire soundscape, and it's a permanent record of everything that's going on in that soundscape. So you're able to pick out species, you're able to pick out different patterns. So it's really one of the most profound ways of understanding biodiversity and looking at biodiversity health. And that's why bioacoustics has become such a popular thing. And the drawback of bioacoustics in the past has been the processing of large amounts of data. If you're thinking about a recording, an audio recording, in the past, before AI and before machine learning, it would take a trained ecologist, a trained ear, about 5 to 10 minutes to analyze a 1 minute recording of a soundscape to pick out all the species in them. So you can imagine how lengthy of a process that would have been. But with AI, we can now process tens of thousands of files, tens of thousands of minutes of recordings in a matter of seconds. So with the advancements of technology, we now can use acoustics in a way that hasn't been done before. And for all those reasons, it is definitely becoming one of the most important ways to understand biodiversity health.
So, what was the idea behind Rainforest Connection?
Yeah, so Rainforest Connection started out of necessity more so than anything else. We are a nonprofit organization, and we started out back in 2014 as um, a to address the need of a very particular project that was near and dear to our heart in Sumatra, at a gibbons reserve. Actually, um, it was a volunteer project at a gibbons reserve, and it turns out that they were spending more time fending off illegal loggers from cutting down trees outside of their reserve than actually protecting gibbons. And there's nothing they could do because there was one or two guards in a big protected, big massive forest. So Rainforest Connection, in its original kind of in the beginning, our focus was to try to help people on the ground that are trying to protect their forests to use technology to amplify the capabilities that they have. So we started out with creating a device we called the Guardian, which was actually made out of a recycled cell phone that people would donate to us from all over the world. And we would use some, off the shelf electronics at that time and a bit of software code to pick out anomalies in the sound. So we were able to help these uh, these 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 people on the ground to help better protect their forest by installing a machine that could essentially act as an alarm system. So that's how Rainforest Connection started. Fast forward to today, Rainforest Connection now is a global organization. We still focus very much on threat detection. The Guardian system has evolved over time. And now there's a huge chunk of our work that's focused on also using sound. So sound is a very important part of what we do. To use sound to study biodiversity, as I talked about earlier, bioacoustics is a very important part of understanding biodiversity health. So now we use sound to study biodiversity, to study species behavior, look at what biodiversity health is. And as a result of that, we created a platform, an online platform called Arbimon, a very popular platform that's now serving over 3,500 scientists in 119 different countries. And the purpose of that is to enable scientists and researchers to use acoustics in their research to facilitate that process. And Arbimon is open and free to use for anyone. Anybody can go into arbimon.org or rfdx.org, and they're able to create an account and start using acoustics to analyze soundscapes.
What are some new projects which Rainforest Connection is working upon?
Yeah, so I mean, I could talk a little bit more about Arbimon and Guardian as well.
Yeah, sure.
Yeah, so at the organization, we have two primary focuses. The first one is what we call threat detection, right? Which is this brute force way of trying to detect threats primarily in a forest. So anything that doesn't belong there. So if you think about illegal logging, for example, illegal logging is a very big problem. It's one of the it's a big contributor to greenhouse gas emission. It's actually more logging contributes to greenhouse gas emission more than all of transportation combined. So if you look at all the ships, planes, trucks, vehicles in the world, deforestation accounts to more greenhouse gas emission than all of transportation. So 1/5 of the global greenhouse gas emission comes by way of deforestation. So it's a very big problem. One big indicator of deforestation is people cutting down trees using chainsaws. Chainsaws make a lot of noise. They're very loud. And a well-trained computer model can pick out sounds of chainsaws. So the Guardian system uses machine learning and AI, and it's fully connected to the network. So it's able to stream in real time. And as a result of that, it could detect the sounds of chainsaws. It could detect any signs of illegal activity. So gunshots, which are indicative of poaching, or vehicles and trucks, which are indicative of people moving equipment or moving lumber back and forth. These are all things that can be detected by the Guardian system in real time. And the Guardian is this device that actually mimics a Cercorpia tree, which is a well-known species in the rainforest. And they get installed on top of the tree canopy. And so we climb up the tree about, usually emergent trees about 100 to 150 feet, maybe 30 to 40 meters, sometimes more. And we install these devices on top of the tree canopy, primarily to get sunlight, but also for communication. They're able to communicate via GSM. They're able to communicate via satellites, and they are self-contained. They power themselves using batteries and solar panels. And they're basically recording the soundscape 24/7. And like I said, they're picking out these very specific threats and analyzing that data. And as soon as they detect a chainsaw, or as soon as they detect a gunshot, they can alert in real time the people on the ground. So the rangers on the ground that are protecting this forest, or the government agency or whatnot, they will receive an alert on their phone that says, hey, a Guardian detected so-and-so in this particular location. So it serves as a real-time way to fight against poaching, to fight against illegal logging. It's been used in over 15 countries around the world. We have lots of projects, some with government agencies, some with local partner organizations, others with indigenous tribes. So it kind of spans across the board. And that's what the Guardian system is for, to help these people on the ground sort of multiply their capability to protect the forest. So that's the Guardian side of things. That's what we call the threat detection. On the biodiversity monitoring, which is where Arbimon comes in, our mission there is to try to bridge the gap between science and conservation. And what I mean by that is that if you look at science, you're studying to be a scientist yourself. If you look at science, a lot of the effort is spent on research, and sort of the end goal or the win for scientists is usually a publication, right? Which sort of deliver deliver the results of whatever the research or the PhD program or whatnot. Now, if you look on the other side of things, which is conservation organizations are the ones on the ground. Usually they're not as sophisticated as, scientists and researchers. They may not have a science or research team, but they are the ones that are on the ground, fighting the fight and working to protect biodiversity and to protect the forest and to protect the ecosystems. And oftentimes we see this gap between science and conservation, where that information doesn't pass through in ample time, or it is too complicated to pass through and be used appropriately on the ground. So hence how Arbimon was born. So Arbimon was created out of a university project, or a couple of our scientists from the University of Puerto Rico. And, we've been sort of developing it ever since, but it was born out of the need for bridging that gap between conservation and action on the ground. Between science and conservation. So science and action on the ground, to try to translate as much of the research and as much of the discoveries to actual actionable items on the ground. And that was the whole purpose of it. So Arbimon is the first web platform that focuses on using sound to be able to analyze it, upload the data, use convolutional neural networks, machine learning models, basically, to analyze this data and be able to get some real insights that could drive action on the ground. So our team, we have a full team of scientists that actually take on different projects from around the world, answering very specific scientific questions. And we do that for our partners, where we answer the questions that they're looking for. But the biggest and the main purpose of that is for us to learn how we can take these discoveries, take these questions that we've answered, and turn them into an automated an automated system that we can put on Arbimon. So Arbimon is the result of hundreds of thousands of hours of our scientists basically doing different projects from around the world. And as we get to understand how things work and how we do the specific things, we'll release features in Arbimon that enables these scientists to make use of these capabilities without the technical expertise. And we make it possible for conservation organizations to understand this data in an easily digestible way. And all of that is available for free, and it's open for everyone. So anybody can sign up. There's no paywall. You don't have to pay anything. You can analyze as much data you want. You can upload as much data you want, and make use of the system. So that's in a nutshell, the Guardian and Arbimon. I know you asked another question first. What was that again?
What are some more of the other projects you are working on?
Yeah, so we have, at the moment, between biodiversity and threat detection, the ones I explained earlier, we have almost 65 projects that are going on at the same time. So the projects that I get excited about the most is usually our projects where we get to work directly with the local people on the ground. So we have a great project in Brazil, in the state of Pará, with the Tembe indigenous tribe. We've been working with them since 2014, helping them protect their land. So that's always a very exciting project to get to work directly with them. But we also have some great partners from all over the world. Humboldt Institute, for example, where we work with them in Colombia, or we have Rainforests, where we work on a restoration project with them in the Atlantic forest in Brazil. There's a lot of projects, a lot of amazing projects that we get to have the privilege to work closely with partners or local communities on. And those are usually the ones that are, to me, the most exciting. And when I get to go to any of these projects myself and be part of the field team that are doing data collection or climbing trees to install guardians, that's always, near and dear to my heart. So I always enjoy that part as well.
So what have been some challenges you have faced, not only throughout the history of Rainforest Connection, but also with the implementation of the various bioacoustic technologies across the world?
Yeah, I mean, I think the challenges are always many, right? So if you're when you look at it, what it boils down to is we're working in some of the most remote, harshest environments in the world. If you're looking at the rainforest or some of these other ecosystems. So that itself presents its own set of challenges, right? You're looking at complications, almost what you plan and what ends up happening on the ground is almost never the same. So you always have to make sure that you're adapting based on the changes that you see on the ground, and making sure that you're making the adjustments that are necessary. So though, just field work itself presents its own set of challenges. I think the other part is as our system grows and as our system gets more and more users and more data. I mean, we're looking right now at somewhere around 2 to 3 million recordings that get uploaded every couple of days. So the scale of where the system is absolutely massive. And 3,500, no, sorry, 4,500 scientists are using it at the moment. So, it's as you scale a initiative like this, it becomes a massive responsibility to ensure the sustainability of such a thing. So that, there's a lot of complications there. There's a lot of whether it is ensuring everything is ensuring the technology is up to date or ensuring that the funding is there to support it or whatnot. I think there's always many, many challenges there. And, us being an ambitious organization looking to grow and expand because we know that the clock is ticking and, the nature's and this biodiversity crisis and the sixth mass extinction that we're going through is not going to wait for us. So this, aggressive style growth to meet the demands of the mission is another area where we face a lot of obstacles and we have to make a lot of adjustments, right? So there's challenges in every single direction that you look at, really.
So how do you think bioacoustics can be improved for conservation, and what do you think are some of the most exciting emerging bioacoustic technologies for conservation?
Yeah, I mean, like I said earlier on the podcast, I think that bioacoustics is one of the most profound ways to understand biodiversity because number one, it is permanent. The soundscape that you collect doesn't expire. It's not like it lasts in a lab for 10, 15 days and you can't use it anymore. It's a permanent record. It's a historical recording of that soundscape. And it's also a record in history that we're never going to hear again because the world is changing, the climate is changing. So the soundscape that you're hearing in the forest near you today is not going to sound the same a year from now or 2 years from now. The world is changing. Species are shifting. They're not waiting for us to come and do something about it. They're adapting as the climate changes, right? So that soundscape is changing. So I think bioacoustics offer this immersive 360-degree view of what's going on in the soundscape. And the advancements of technologies where, machine learning and AI has become a advanced to a level that it can pick out specific species sound better than a human ear can hear. I think that facilitates the big data problem of having all these acoustic recordings that you need to analyze into species presence. So you can create occupancy maps and predictions of where species are located and so on and so forth, all important elements of assessing biodiversity health. So that's why acoustics is so important. And, acoustics has advanced heavily in the last decade, I would say, from going to, these biologists that will have their field gear on with these huge shot mics hiding behind a bush, waiting for recording a sound of a bird on top of a tree to these passive devices, these little tiny devices like our partner in Open Acoustics in out of the Imperial College in London do with the audio moths, which are fantastic devices. So these devices that are this tiny, cost $100, and you can put them in the field for weeks or if not months, and they can record the entire soundscape to the data analysis, like I said. So acoustics has advanced a lot. I think where the breakthrough of acoustics is going to be in the future is how well we can merge acoustics with other important data sets that are that are available, like eDNA, for example, or camera trapping. How do we mix all of this data together and start making sense of biodiversity health? I think other advancements in acoustics happens around the technology of processing data itself. So, namely AI. At the moment, most of the AI applications that you see out there are using what's called using those convolutional neural networks, which are basically supervised learning techniques. What that means is that you have to provide the model multiple examples, hundreds of examples of positive and negative detections of the species, and train it over time so it could start recognizing species presence, to advancing that to unsupervised learning techniques. There's things called one-shot learning, and there's other methodologies. We've actually published a couple of papers on this, including creating a tool on Arbimon that's called cluster analysis, which allows the computer to detect, or the machine learning model, to be able to detect species presence, even unknown species to you, the scientist, in an unsupervised way, where it could start making clusters and detections of these species, and then you can identify them later. So I think these techniques, these improvements could very much facilitate how we process acoustics data. So there's so many things that are there, and so many things that have been done already. So, but that's in a nutshell where I see some of the advancements in acoustics and also the importance of it.
I actually didn't realize that the audio mods were from Rainforest Connection. One of my colleagues is using it quite extensively for her master's thesis.
They're not from Rainforest Connection. There is a wonderful company out of the UK. They're all, I think, alumni of the Imperial College of London, called Open Acoustic Devices. But they're good friends of ours. If you go on their website, there's a link to Arbimon right there. So we have a great partnership, and they are the makers of the audio moth. So credit goes to them. They are the ones who created the audio moth, not Rainforest Connection. We're power users of it, I would say.
I'll edit that part. Okay. So yeah, what is your vision for the future at Rainforest Connection, and how can individuals contribute to your organization?
Yeah, I mean, I think that the future for us revolves around how do we simplify all this data we have in a way that it becomes very easy to understand what biodiversity health looks like anywhere in the world. Right now, it's a pretty complicated process that only a scientist could interpret what biodiversity health is like in a particular area. So I think what it will boil down to is getting to a point where we have a score by which we could understand how healthy the biodiversity is for a particular forest. And I think we can take that score system and we can extend it to the entire world, where we can even predict the score with a certain level of confidence. So it'll be a 2-tier score with a confidence percentage, for example, where we can predict what biodiversity health looks like, even in places where we don't have any data, because we have nearby locations that have similar biome, that have similar climatic variables, etc. So that's where we are. That's what we're aiming to do. We're aiming to get to a point where we can showcase a map where you can see biodiversity health score for anywhere in the world. And what that's going to do is that's going to drive regulators, policymakers, conservation organizations, and funders to direct their efforts into these areas that are biodiversity hotspots, or in these areas that need the most help in terms of biodiversity, in restoring biodiversity. So that's, I think, where our future focus is going to be.
And what has been your greatest learning from your conservation career?
Yeah, I mean, I think I come from a world of in the last I've been in the conservation world for the last 7 years, but prior to that, I was very much an entrepreneur focused on the for-profit world and growing businesses and growing companies. That's what most of my experience in, and then that leap for me has been something that's been one of the greatest decisions in my life, but also a very humbling decision, and I think fulfilling one as well. And I think that it as you go into the conservation world and you start looking at a cause that's greater than your own personal ambitions, I think it changes the way you look at things. So for me, it's been a great learning opportunity to go through that journey and go through that process and see how we can focus all of our efforts towards one greater cause versus, like I mentioned, personal ambition. So, it's been um, lots of learning for me, lots of new things that I've not been accustomed to before. This ability to sort of join hands with other organizations so we can work towards a single mission, this ability to share our learnings with others and others share learnings with us. All these things were very, very unfamiliar territory for me in the past life, so to speak, when I was in the for-profit world. So these are all new learnings that I've picked up along the way, that have been very, very instrumental in the way I think now. Um, and how people can help. I think they can help in a lot of ways. I think they can help on a personal level where they could educate themselves more um, about what's going on and how the world is changing and how climate is changing and what's the effects of biodiversity. You see species and you think species are cute and they look great and we should um, conserve species, but try to understand the real reason why. This symbiotic relationship, this great partnership that species have with the world and the environment, and how it's a revolving cycle and with major dependencies. Um, there's so many great examples on how species are so dependent on each other and dependent on the ecosystem and the trees and so on and so forth. So educate yourself more on what does that mean, and what's happening in the world. And hopefully that could drive you to change some personal behaviors that could positively contribute. So I think that would be number one. The second one is, reach out if you think there's something that you can help with. If there's a partner or somebody that that could contribute to our mission or could partner with us to work on a project, or if there's a community that's in need of our technology that we've explained, or funding opportunity. Obviously, with an organization like us, having to provide all these services for free to everyone, funding is always needed for us, right? Always an important thing. So if any of these opportunities are there, yeah, I mean, definitely reach out to us and help. And I would say the last piece is try to experience some of this technology yourself to kind of get yourself immersed. One of the best ways to do that is actually go to your app store, whether it's Android or iOS, and download the Rainforest Connection app. And that will allow you to listen to some of these devices, some of these guardians that are broadcasting from the middle of the jungle. You can listen to the soundscape and listen to these things, and that's a good way to kind of immerse yourself in what's going on in the world. So feel free to do that and check it out. Of course, it's free. So just download it and go through the features that it has. Yeah, so I think that's about sums it up.
That is my final question for today's interview. Thank you so much for your time. It is a really big pleasure to talk about your great work.
Thanks. Appreciate it. Thanks for having me, Anish.
And that's the end of this episode. I hope you enjoyed and learned quite a bit about bioacoustics and how artificial intelligence is becoming increasingly useful for conservation. If you did learn a lot, don't forget to subscribe and share.